Welcome to today's lesson, wherein we are going to derive the homostate pressures from the ideal gas equation, which says that PV is equal to nRT. And we know fully well that P stands for pressure, V stands for volume, N stands for the number of mole, R stands for the universal gas constant, and T stands for temperature in Kelvin, right? So now we can use this particular equation to derive the homostate pressure that says P is equal to mRT. This is homostate pressure. This is molarity. This is the universal gas constant, and this is temperature in Kelvin. Okay. Now we have this. Let us understand something, right? So we have pressure here, and we have homostate pressure right here. But the fact is that they share something in common, that is pressure. So it tells that we should first make pressure the subject of this particular equation. And if we had to do that, we can say that we can express both sides by the volume and both sides by volume. We have volume here and volume right down here. So that means that this is going to cancel with this volume right here. And we have V here, but there is no volume up here also. So we leave that. All right, so after we have done that, we can rewrite our equation that says, or that now says, pressure is equal to the number of mole times the gas constant times the temperature. We now have this, all divided by the volume. So remember, we want to derive the homostate pressure from the ideal gas equation. And we know fully well that this particular letter here, M, is molarity. We can say that molarity is equal to the number of mole divided the volume of the solution in liter. So now that we have given this, or we have this, and if you look right here, in this particular area, you will notice that we have mole up here and we have volume right down here. So we can replace them as molarity, because molarity says mole divided volume, and we have mole right up here and we have the volume right down here. So we can now replace them with what? Molarity. So we can rewrite this equation that says N times R over V, and we can say this can now be replaced as capital M. We maintain this pressure right here. So M times R times T. So this becomes the homostate pressure formula. But again, we have P right here. And this is P. So this is pressure, this is homostate pressure, but it is also called P. So to replace this pressure with P, we can just say P is equal to mRT, homostate pressure. So that's how we were able to derive the homostate pressure from the ideal gas equation. Is that not simple? All right, so thanks for watching, and don't forget to subscribe to my